This section is on the three-dimensional Cartesian coordinate system and a little bit of what we can do with that. For three dimensions, you're going to have an x-axis, which we usually draw it as a diagonal here coming out of the page, so to speak, a y-axis, and a z-axis. And rather than 4 quadrants, we have our 8 octants. So our x comes out, y goes this way, z goes up. So in any coordinate system, it's important surely to know, well, how do we plot points? And so one way to think about it, if you want to do 2, -3, 3, which is this point here, first we go out 2 in the positive x direction, and then we have to go 3 in the negative y direction. So this distance here has to correspond to this distance, so that's why you write it, you draw it as a parallel. And then finally we have to go to 3 in the y height, so this distance 3, I transpose that over to here. Let me draw an example out for this particular one. If I'm going to do this is let's try 5 -2, 2. We'll plot that point. So we have our x, we have our y, and we have our z. So we go 1, 2, 3, 4, 5. So we go 5 in the x direction, and then 2 in the negative y direction. Now that doesn't mean that I go back over to line up with 2. It means that I have to transpose that distance over here. Right? Everything is sort of parallel that way. So now I'm over to here, and then I got to go to a height of 2. That doesn't mean I go all the way up to here. It means that I take this distance here and I transpose it, bring it over, and so now I'm over here. So my final point is right there. So imagine you come out this way, left, and then up. Okay. Distance formula is the exact same you'd see in 2 dimensions, except now we have to also include the change in z coordinates. So distance between 2 points in space, change in x squared plus change in y squared plus change in z squared, and take the square root of that. And so if you want to find the distance between 0, 1, 3, and 1, 4, -2, you do 1 minus 0 squared plus 4 minus 1 squared plus -2 minus 3 squared, and simplify all that and you get rad 35. Just like in 2 dimensions, the midpoint formula is very similar as it was with distance formula. You average the x's, you average the y's, but you also must average the z coordinates now. So x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. And so finding the midpoint in space between these two, 5 plus 0 over 2 is 5 halves, -2 plus 4 over 2 is 1, 3 plus 4 over 2 is 7 halves. Now we have the equation of a sphere. When you derive the equation of a circle in geometry, you think of it as all the points equidistant from a single point, that being the center in a plane. But now we're not saying that's to be a plane, it can be in space. So that's why we have not just the x minus 8 squared and the y minus k squared, but also the z minus j squared. So, and it comes just very much out of the distance formula for 3 dimensions as opposed to 2 dimensions as well. So hkj is our center and r is our radius. So if we have a center of 2, 4, 3 and a radius of 3, x minus 2 squared plus y minus 4 squared plus z minus 3 squared is equal to 3 squared. Here is a different type of problem. We're given this equation. You want to find the center and radius. This is not in standard form, and so you've got to complete the square with your x's, with your y's, and with your z's. And so we group the x parts together, x squared minus 2x, group the y parts together, y squared plus 4y, group the z parts together, z squared minus 6z, and add in the parts we need, making sure to also add them to the right, 1, 4, 9. Then we can complete the square and write this way. So we've got a center at 1, -2, and 3, and a radius of radical 6. The trace of a sphere is where a sphere hits a particular plane. If you want to find, for instance, the xy trace of a sphere, then z must be 0. And so you plug in 0 for z, and you would just subtract the 4 squared to the other side. And so your trace would be a circle of this shape, of this equation, which makes sense. If a plane cuts through a sphere, you would expect to see a circle. Okay, a few more sample problems. We're given these 3 points. We want to find out what type of triangle they constitute in 3D space. And so let's find the distance between these points. So from x to y, we use the distance formula, 2 minus -2 squared, -1 minus 5 squared. You could put negative 620 squared, but it's the same as 6 squared, so it doesn't matter. 2 minus 0 squared, and you get rad 56. For yz, we do negative 2 minus negative 4 squared. 5 minus 4 squared, 0 minus 1 squared. It's actually negative 1 squared, but again, it's the same as positive 1 squared. And finally, from z back to, this should be an x. From z back to x, we use distance formula, and we get rad 62. And so as far as what type of triangle this is, well, if you do rad 56 squared plus rad 6 squared, you get rad 62 squared. So it satisfies the Pythagorean theorem. So apparently this is actually a right triangle in space. Okay, we want to write the equation of this sphere given these two diameter endpoints. These are endpoints of a diameter. So we know that the center is halfway between the endpoints of the diameter. So first we'll use the midpoint formula to find the center. So we add the x's, divide by 2, add the y's, divide by 2, add the z's, divide by 2, and simplify. So there's our center. Now if we want to get the radius, a couple different ways to do it. The way I do it here is I say the radius is 1/2 of the diameter, and the diameter is the distance between these 2 points. And so square root of 2 minus negative 1 squared plus 4 minus negative 2 squared plus 6 minus 2 squared. So this is my distance formula between these 2 diameter endpoints, and the radius is half of that. So the radius is going to be half of rad 61. So then I've got my center points. So it's going to be x minus half squared plus y minus 1 squared plus z minus 4 squared is equal to this guy squared. And when you square a half, you get a fourth. When you square rad 61, you get 61. So it's 61 divided by 4. Here is a problem where you want to find the center and radius of the sphere. You've got to complete the square. Well, x squared, there's no other x term, so you're done there. Y squared, you've got to write it as y squared minus 8y, and to complete the square, you've got to add 16. And then for z squared minus 6, you've got to add 9. The 13 I'll bring to the right side, so that's why I've got a negative 13 over here, but I've got to add 16, and I've got to add 9. Since I added to the left side, I got it to the right. So then I complete the square with these, and as you can see then, this becomes 12, so my center is at 0, 4, 3, and my radius is rad 12, which is 2 radical 3.